Hi everybody, hopefully you got a chance to try out these problems just to see how you're doing with everything. So remember, my hint was before that you wanted to first figure out what the ordered pairs are for the original images, and then use K, which is your scale factor, to help you to figure out what the new coordinates would be of each one of the vertices. So if I look at A, the original pair or ordered pair for A would have been at -8, -3. For B, it would have been at -5, -4, and C would have been found at -2, -3. Now, if I'm using the dilation, using the scale factor, we know that K equals 3 is a number that's bigger than 1, so this is definitely going to be an enlargement. Since it is centered around the origin, you're going to be taking that scale factor of 3 and multiplying it to both the x and y values. So A prime would then be located at -24 and then -9. For B prime, it would be located at -15, -12, and C prime would be located at -6, -9. And again, we're not going to plot these, but we can see that that's going to be a much bigger image. All right, and then finally, when you look at the second image, the first ordered pair, and I have to be careful with these, you might want to notice that these are going up by 2s on the x and y axis. So M would be located at -10, 0. N would be located at -6, 0. O would be located, K would be located at 1, 8. And L would be located at 2, 4. When I look at my scale factor, it is 1/2, which since that's a number that's between 0 and 1, that means that we're going to have a reduction. So when I take that 1/2 as a scale factor and multiply 1/2 to both the x and the y values, here are my new ordered pairs. M prime would become -5, 0. N prime would become -3, 0. K prime would become 1/2, 4. And L prime would become 1, 2. So hopefully you got those correct. Hopefully the different values that went up by on the x and y didn't fool you. But remember, a dilation is not an isometry. It's showing you that a shape has been either reduced or enlarged. The shapes will be similar to one another, but will not be congruent, which makes this type of transformation the only that is not an isometry. So please let me know if you have any questions, but move on to the next activity after you are finished.